If sine 40 degrees is equal to p, write each of the following in terms of p.
Question 5.1.1. We are given sine of 220. We have to write it in terms of p.
Using this trigonometry Cartesian plane and reduction formulas written in blue and also in green.
In grade 12, we're going to use the circled reduction formulas mostly. And remember, we are given sine of 220. And we know that 180 degrees plus 40 degrees is equal to 220 degrees. Therefore, sine 220 degrees will be rewritten as sine of 180 degrees plus 40 degrees.
And by the aid of the trigonometry Cartesian plane, we can see that 180 degrees plus theta lies on the third quadrant.
Hence, by using cast, on the third quadrant only tan is positive, therefore sine will be negative, giving us negative sine of 40 degrees from this reduction formula, which is equal to negative p, since we know that sine of 40 is equal p, as given on the statement.
Question 5.1.2. We are given cosine of 50 squared.
We know that 90 degrees minus 40 degrees is equal to 50 degrees.
Therefore, this can be rewritten as sine of 90 degrees minus 40 degrees.
I made a mistake. There is actually still cosine of 90 degrees minus 40 degrees, all squared.
From the trigonometry Cartesian plane, we can see that 90 degrees minus theta lies on the first quadrant, where all trigonometric ratios are positive.
And cos of 90 degrees minus theta.
Now considering cosine of 90 degrees minus 40, all squared, will result into its cofunction sine 40 degrees squared,
which is equal to p squared, since we know that sine of 40 degrees is equal to p, as given on the statement. Question 5.1.
Cosine of negative 80 degrees is equal to cosine of positive 80 degrees. And this can also be rewritten as cosine of 2 times 40 degrees.
And by using the double angle rule, we know that cosine of to alpha is equal to 1 minus 2 sine squared alpha.
Therefore, cosine of 2 times 40 degrees can be rewritten as 1 minus 2 sine squared 40 degrees, which is equal to 1 minus 2 p squared.